Live. Okay, so say I have this prism, and even though it doesn't look like it, I'm going to call this side 3. I'm going to call this side 4, even though it doesn't look like it. And I'm going to call this side 5, even though it doesn't look like it. Okay? And I'm going to double everything. So I'm going to tell you these two shapes are similar. So now this side is 10, this side is 6, and this side is 8. So the similarity ratio, which you didn't learn about on your PSATs, right? Is in the ratio 1 to 2. Yes? 2 of these for every one of those. How many of these little boxes could fit inside this box? 4? 2?
6.
More than 4?
12.
8?
9.
Trevor? We don't know. Okay? Well, let's figure it out. How would I find the volume of the little figure?
3 times 4 times.
Right? 3 times 4 times 5. What's that? 60. Let's say these are square inches. Okay? Inches, inches, inches. So 60 inches squared. Or cubed, sorry. Inches cubed. Let's figure out the volume of this. Well, 6 times 8 times 10. What's that? Volume of the big one, big guy, is equal to 6 times 8 times 10, which is 480, okay, inches cubed. How many times as big in terms of volume is the big box in terms of the little box? 8 times as big, right? 8 times as big, which is why elephants have big ears. I'm not making a joke. It is why elephants have big ears. Because say I have an elephant. Here's an elephant. I have a pet elephant at home. Okay?
You went all the way from Africa and smuggled it here?
Yeah. Here's an elephant. Tusk, tusk. Doesn't look like an elephant.
Looks like a hybrid of a pig and a bird.
Okay. So here's my elephant. And then I have a bigger elephant. They have big ears, though. Elephants have big ears. Okay? Big ears. Here's another elephant with big ears. Here's his trunk. His trunk. I'm not very good at drawing elephants, you could tell. Anyway, so here's my other elephant.
Now you're just failing at genetic
Okay.
editing.
By the way, you know what you get if you cross an elephant with a rhinoceros?
You get a rhinoceros.
Elephino.
Dang it.
Whoa!
I got that.
I got it. Oh, good. We got it. We got it. Okay. So in any case, this elephant is twice. Say this elephant is twice as big as this elephant. So say this elephant is the ratio of this elephant is 1 to 2. What's going to be the ratio of their volumes? 1 to 8. Okay, we're going to talk about this conjecture in a minute. But 1 to 8. 1 to 8 would be the ratio of the volumes, right? So weight is a function of the volume, right? And this is true story. I mean, I'm not just making this up. How do people, how do elephants, how does any mammal cool themselves off for the most part?
Water.
By sweating and by the surface area, okay? So like elephants, they have very huge mass. Like if their volume is like 10 times as big as our volume, okay? Their surface area is, if their volume is 10 times as big, their surface area is only going up as their square, but their volume is going up as the cube of our ratio. So their surface area, they have less proportional surface area than a human does. And that's why they have evolved to have very big ears, because with those big ears, they have more surface area to cool themselves off and to flap their ears to cool themselves. It's true. That's why elephants have big ears. It's true. Anyway, okay. So that's that. That's that problem. Let's do one with cones. Okay. So say I have 2 cones. I can do that. Next, where's a cone? Here's a cone. Here's a small cone. Small cone. Let's make a small cone. There's a big cone. That's not a cone. Make another cone. That's not a cone either. Let's try that again. There's a bigger cone. Okay. Say this has a say this has a radius of 2, and this is 5, and say these cones are similar. Oh, how am I going to do this? Let's just say that they're similar, and the ratio of their ratio is the ratio of their sides. Side 1, which is the same as radius 1 to radius 2, is equal to 2 to 5. Well, let's just make this one. If this is 3, what would be this? What would this be? How would I figure that out? Who can tell me how I find x? It's not going to be a nice even number. 7.5? Let's see. 2 is to 5, as 3 is to x. Okay, so 2x equals 15. Trevor was exactly right. X equals 7.5, right? Or, so x equals 7.5. So the volume 1, let's find volume 1 to volume 2, okay? How would I find the volume of the small cone? How would I find the volume of the small cone? Pi times what squared? 2 squared times the height, which is 3, divided by 3. That's how I would find the volume of the small cone, right? How would I find the volume of the big cone? Pi times what squared? Pi times what squared? 5 squared, right? Times 7.5 divided by 3. So this has a volume. This one I could do. I could cross those out, and I could get that that's 4 pi, right? Couldn't I? Those 3's cancel out. And here I get 25 divided by 3 times 7.5. That's kind of an ugly number, isn't it? What is that number? 25 times 7.5. It's the same as 25 times 2.5. What's 25 times 2.5? 25 times 2.5? 60, I think. Is it 62.5? I believe that's 62.5. I just did that in my head. So these pi's cancel out, so I get the ratio of the volumes is 4 to 62.5. Yes? Yes? No? Another way to write that is, how can I write that as a whole number? Double it. What's 4 doubled? 8. What's 62.5 doubled? 125. Right? You guys with me there? The moment before it just froze. Oh, there, it unfroze. Okay? Touch up. 125. 8 to 125. Does anyone see another way I could have found that volume ratio? Using the ratio of the sides. Not cube root, cubing them, right? What's 2 cubed?
8.
What's 5 cubed? 125, right? 8 to 125. So we have, so I could have just, so if the ratio of the sides, this is a conjecture, okay? So if the side ratio, where are those conjectures? I have to find them, okay? Hold on. I'll just write it. It's on your conjecture sheet, but it says that in 2 similar figures, you should write this down, or you should have it. What does it say on your conjecture sheet? Okay, if corresponding edges rated similar ratios. Okay, if 2 similar figures. Please stop that. Figures. Let's try that again. Figures are in the ratio m to n, then the sides, then the volumes, please don't do that, then the volumes are in the ratio m cubed to n cubed. Okay? And that has to do with weights too. So if you have a person who's twice as tall as another person, and all their other proportions are twice as big, how many times more are they going to weigh?
8.
They're going to weigh 8 times as much, right? So if you increase the size, that's why the Titanic sunk. Seriously though, because
Yeah,
they made.
I heard it's actually made of iron, so it's pretty much sinking the water.
Yeah, because they made a model of it, right? And they put the model in the water, and they go, "Oh, the boat floats, works pretty well, right?" But when they made it true scale, the volume goes up cubed the ratio of the side. So proportionally, it's going to weigh, like the cube is proportionally the weight to the surface area. Surface area is what makes it float. And so it weighed a lot more proportionately than the model of it, and that's why I don't know. It also is an iceberg. That didn't happen. So, but seriously.
But if they actually didn't consider the proportionality of the cubing and all that,
They probably did.
Wouldn't that ship actually just sink in the water the second they tried to take off with it or so?
I don't know.
Especially with all that people on board.
Yeah. Yeah. What Han said. Okay. So two let's see. Two spheres have the ratio of their volumes, have the volume ratio eight to 64. What is the ratio of their radii, sorry about my bad radii, and their surface area? Surface, that's a U. Surface area. How would I do that? If they're about, so you have two spheres. Let's see if I can draw a sphere. Sphere. Ah, here's a sphere. Drag, here's a sphere. 8. 64. Here's 2. So, why did I write ray shunt? I do that a lot, okay? So,
Ration? Are you really that hungry?
if this, so their actual volume isn't 8 and 64, but their ratio is 8 to 64. How do I find the ratio of the sides if I know the ratio of the volumes? What cube rooting it? Do you know how to cube root things on your calculator? I kind of showed you the other day. But so you would have to, so if the ratio of the volumes is 8 to 64, okay, volume 1 to volume 2 is 8 to 64, then the side length of 1 to the side length of 2, which is the same as the radius of 1 to the radius of 2, is equal to the cube root of 8 to the cube root of 64. Okay? What's the cube root of 8? 2. What's the cube root of 64? 4. What does that reduce to? 1 to 2. What's the ratio of their surface areas? How do I find the ratio of the areas if I know the ratio of the radii? What do I square it? Okay. So the So the ratio of their areas, okay, the ratio of the area 1 to area 2 is either 2 squared to 4 squared or 1 squared to 2 squared. 1 squared to 2 squared, which is 1 to 4. Okay? See how you do that? So if you need to find the ratio of the sides from the volume ratio or the weight ratio, and they're similar figures, you need to cube root it. You can't go from the volume to the area. You have to go from the volume to the side length, square the side length to get the area. So you have to go backwards and forwards. You know what I mean? Okay? Let's do one more. The ratio of the areas. The ratio of the areas. Let's see if you guys can do it. Of the areas of two similar statues. Two similar statues. Okay. Statues? How do you spell statues? Statues is, let's 36 to 25. Okay. Find the ratio. That says find. Find the ratio of their volumes. Okay. And this is a good problem. If the small statue weighs 2 pounds, how much does a big statue weigh? You guys try that one. Try that one. Go ahead. I gotta do the math because I just made up this great problem. I have to pause. Go ahead, Joey. Try to do this problem. Get it right. Okay. So the area ratio is going to be 6 to 5, right? And then I want the volume ratio. Volume 1 to volume 2 is 6 cubed to 5 cubed, which is equal to 216 to 125. Yeah? Okay? If the small one weighs 2 pounds, volume and weight are proportional. If the small one weighs 2 pounds, how much does the big one weigh? So you put a 2 down here and you put an X up there. See the way you do that? Okay? So you get 2 times 216, what's that? 512 equals 125x. So the big one weighs 512 divided by 125, which comes out to be 3.4243 pounds about. Okay? About that much. See the way that works? Yes? This can be a little confusing, okay? So, I'm going to let you work on your homework now, okay? Your homework, yay, and I'll help you as you encounter difficulties. Page 610, is that right?
616.
Oh, 616 is it 1 through 11?
Mm-hmm.
616, 1 through 11. So you could start, show work. Show work. All right, I'm going to pause here. That's my cutting edge video for the day. This is Mr. Leader saying goodbye and good night. All right, okay. So, how do I stop it?